Hello AP Stat students, Mr. Hazelhorst here with your second video from Chapter 9. What we're going to take a look at today is we're going to start to actually put this abstract idea of a sampling distribution into practice. How are we actually going to use it as we move forward? All right, and we're going to look at the sampling distribution over the next two videos in practice. And what we're going to focus in on today is the use of the sampling distribution with regards to sample proportions. And proportions are a very common statistic that we use in a lot of different settings. You've probably seen proportions many times in different statistical settings. I know you have throughout this course already. And so we want to look at some examples first off of what does a proportion look like in statistics. And they're very simple. So here you see three examples of proportions from statistics. The first one you probably have seen something similar to this on commercial advertisements before. But Tylenol is recommended by 8 out of 10 doctors. Now, how did they come up with that statistic? Did they ask every single doctor in the world or the nation or whatever their population is, do you recommend Tylenol? My guess is no, they didn't. They probably dealt with a sample, and from their sample, they found approximately 8 out of 10 recommend Tylenol. All right? And so they're representing their data, their statistic, as a proportion. Okay? Second one, a recent survey found that only 16% of Americans trust lawyers. Again, did they poll every single American? I doubt it. Some sort of a sample. All right, and then they simplified that data down. They represent it in a proportion, and we've got it. All right, and again, our last one, 2 out of 3 schizophrenic patients are men. All right, did they deal with every single schizophrenic patient? Possibly, but more than likely they dealt with a sample, and again, they're just representing their data as a proportion, okay? Now, before we leave the slide, one connection that I want you to make is to think about how does this data relate to what we talked about in Chapter 8, specifically with a binomial distribution, all right? If we say that Tylenol is recommended by 8 out of 10 doctors, all right, could we fit that to a binomial distribution, okay? So let's just go through the characteristics of a binomial distribution. First off, do we have only two outcomes in this setting? Well, the answer to that would be yes. They either recommend Tylenol or they don't. Okay. Second, do we have a fixed number of trials? All right. Well, we could say technically yes, we do. We have 10 doctors that this has been simplified down to, and even if we had more detail about this, if we knew that they polled 2,000 doctors, right? Well, we would still have a fixed number of trials there. Maybe this number's been reduced down, but again, at some point we had a fixed sample size that we were working with. And then finally, as long as they selected these doctors at random, we could safely assume that they're independent. And so all of these proportions could follow the idea of a binomial setting. So as we work today and put sampling distributions into practice with a proportion, you're going to see we relate a lot of things back to the binomial distribution and things that we covered in Chapter 8. All right? So let's jump into what we mean by sampling distributions in practice here. Now, when we say sampling distributions in practice, it's a very simple process. All right? Ultimately, our goal is going to be to use the normal distribution. All right? That's a distribution we've used in a lot of different settings so far in this class, and we're going to continue to use the normal distribution in as many settings as we can over the course of this class. All right? And we know how to use the normal distribution, so it should be pretty familiar to us. We should be comfortable with that, and so that makes our life pretty easy in statistics. So when you look at our process here, to actually use a sampling distribution, step number one is to make sure that a normal distribution is appropriate to use. All right, and we'll talk about how to do this here in a moment. All right, the second step, once we've determined that yes, a normal distribution is appropriate, well, we need to know the key characteristics that make up that normal distribution. And as we defined back in Chapter 2, all normal distributions are determined based on a given mean and standard deviation. So if we're going to use the normal distribution, then we need to find the mean and standard deviation of that normal distribution. And those are going to come from the mean and standard deviation of the sampling distribution. And then finally, our last step is to actually do our calculations using that normal distribution. And this should be the step that we are very comfortable with. We've calculated with the normal distribution many times in this class. Hopefully by now you know you have two options. You can either use z-scores, right, to do your calculations, which would involve your gold packet as well, or you can use your calculator. Now, in these examples that I work in class, or not in class, but on the video, I'm going to use the graphing calculator. So if you have yours with you, you might want to pull it out, and we'll look at how to do that. Again, that's how I'm going to work through the examples today. All right, so let's start out with step number one. How do we make sure that a normal distribution is appropriate to use? So here's the process that we're going to go through to make sure that a normal distribution is appropriate. Now, remember what we said earlier. Proportions are very similar to a binomial distribution, okay? So understanding that, we can think back to Chapter 8, and we already know some conditions that have to be established in order for the normal distribution to be used. So if I skip down to rule number 2, notice that that's one of the things that we state, all right? Just like our binomial distribution, as long as n times p and n times 1 minus p are both greater than or equal to 10, well, the normal distribution is appropriate for us to use in this setting, okay? Now, we also have rule of thumb number 1. All right, it's very important in statistics that we deal with a sample size that is appropriate for our population, right? And that means we can't have a sample that is too large. If we get too large of a sample, we're just better off working with the population itself, all right? So our first rule of thumb is we need to make sure that our population, all right, is 10 times larger than our sample size. So capital N represents our population size, lowercase n represents our sample size, all right? And this will be a very easy assumption for us to make, and you'll see how we do that in some example problems here in just a moment, okay? So it's very easy for us to determine whether or not a normal distribution is appropriate for us to use, all right? So once we determine that it is, our next step is to find the mean and standard deviation. So let's talk about that here. Now this is where that abstract idea of a sampling distribution comes into play. All right, remember from our first video of Chapter 9, all right, we determined that the mean of a sampling distribution is really the same as the mean of the population that sampling distribution is representing. And hopefully we also know that the sampling distribution is less variable than the population distribution. All right. When I say less variable, you know, how that applies to us and how that impacts us is what it means is the sampling distribution has a smaller standard deviation than the population distribution does. Right. The sampling distribution becomes more centered on the mean. All right. And those were some big concepts that we tried to kind of to show in that first video. All right, so let's look at how those things relate then to the sampling distribution of a sample proportion. All right, well, if we're dealing with the sampling distribution of a sample proportion, we know that the mean of that sampling distribution is the same as the population proportion. All right, and this is what that's going to look like in symbolism. So when I look at this first bullet point, the mean of the sampling distribution of p hat, right, well, I can represent that with this symbolism right here, the mean of p hat. Right, so it's saying if I took a bunch of p hats and I found the average of them, well, that should come out to be the value of the true population proportion, p. Okay? Our second bullet point tells us how we find the standard deviation that we're going to use in our sampling distribution. All right, and it says the standard deviation, so the standard deviation of the sampling distribution of p hat. So the standard deviation of p hat is equal to, and here's our formula, all right, the square root of p times 1 minus p over n. Now this formula has a strong connection to the standard deviation of a binomial setting, which remember was the square root of n times p times 1 minus p. And we've already established that there's an important connection between proportions and binomial distributions. Now, this formula is not exact, but if you look on page 582 in your textbook, you can follow through the proof of how we get from the binomial standard deviation to the sampling distribution standard deviation. And I don't expect you to know that, but if that's something that you want to see where that formula came from, you can look at page 582 on your textbook, and And I won't go through that on the video to save us time. All right? So that's how we find the mean and standard deviation. So once we determine that a normal distribution is appropriate, we find our mean and our standard deviation. Well, then we're ready to work an actual example problem. All right, so let's do that here. Show you what an example problem looks like. And again, I think you're going to find this pretty easy. So this example problem says, a poll asks a simple random sample of 1,500 first-year college students whether they applied for admission to any other college. In fact, 35% of all first-year students applied to colleges besides the one they are attending. What is the probability that the random sample of 1,500 students will give a result within 2 percentage points of this true value? So there's our problem, all right? So again, we can see that a sampling distribution will be necessary because we're not dealing with one student, all right? We're dealing with a sample of 1,500. And that's where the sampling distribution comes into play. So in order for us to do these calculations, the first thing we need to do is make sure that our normal distribution is appropriate for us to use, all right? So let's do that first off, all right? Again, we know we have two things that we need to check, all right? So we're going to call these our conditions. So our first condition, again, we need to say that our population is 10 times larger than our sample. All right, so how we're going to do that in this problem, we're just going to make a simple statement. We're going to say that we assume there are more than 15,000 first-year college students. Now, if that's true, which I think we're safe in assuming that, then we meet condition number one, all right? So we're going to assume that condition number one is met. Next thing we're going to do is we're going to check for normality, all right? We're going to make sure that a normal distribution is appropriate, all right? So to do that, we need to make sure that n times p and n times 1 minus p are both greater than or equal to 10, all right? So our n value is 1,500. Our p value is 0.35. Right? This would be equal to 525, which is greater than or equal to 10, all right? And then 1,500, come on pen, times 1 minus p, which would be 0.65, and that comes out to be 975, all right? Both of those numbers are greater than or equal to 10. And because they are, the normal distribution is appropriate. All right. So now that we've determined that, let's go ahead and actually apply the normal distribution. Okay? So I'm going to clear my drawings here, and we'll make some room so that we can show the actual work, all right? So we showed that a normal distribution is appropriate. Now we need to find the mean and standard deviation of this sampling distribution, and then we can set up our normal distribution, right? Well, we know that the mean of p hat is equal to p, which in this problem is 35%, right? And we know that the standard deviation of p hat is equal to the square root of p, so 0.35, times 1 minus p, all over n, 1,500. All right, so our sampling standard deviation comes out to be 0.0123. So now we have the mean and the standard deviation. All right, now we're ready to apply our normal distribution. Well, again, anytime we use a normal distribution, I highly recommend you to draw it out first to help you set it up. And I think some of you have gotten away from actually drawing out the normal distribution. All right, so let's do that here. All right, so we have a normal distribution. We know the mean is 0.35. And what we're being asked here is that our sample proportion will give a result within 2 percentage points of this value, 0.35. So that means we're trying to find the area from 0.33 to 0.37. So we'll shade in our normal distribution there, and that's the area that we're trying to find. Okay. So now again, at this point, you have two options. You either use your z-score and gold packet, or you can use your normal CDF, and that's what I'm going to use in this problem. So here's how our normal CDF would set up. All right, I don't know if I'll have enough room here, so just kind of bear with me here. But we'd have the normal CDF. All right, our lower bound in this problem is 0.33. Our upper bound is 0.37. Our mean is 0.35. And our standard deviation we found above is 0.0123. So there's our command for our normal distribution. Again, we've verified that a normal distribution is appropriate. We found the mean and standard deviation of that, so now it's just a matter of doing our calculations. And when we do that, we find out that there's a probability of 0.8961 of our sample proportion falling pretty close to this population proportion. And so that's how these problems work. They're very simple. Again, very similar to how we worked with a normal distribution before. The only difference we have now is that we need to check and make sure a normal distribution is appropriate first, and then find the mean and standard deviation, and then do our work. All right? So as always, if you have any questions over anything that you saw in this video, please make sure you mark those down on the form. And again, hopefully everything clicked here and you can see some similarities to how we've used normal distributions in the past. So everybody have a great day, and we'll see you soon.
Made with Doodlecast Pro.